I'm Don Wysocki, Extension Soil Scientist with OSU at Pendleton.
Yes, I am Stuart Wiest, Soil Scientist with the Agricultural Research Service.
Good morning. I am Hero Gulani with USDA Ag Research Service in Pendleton.
Good morning, Mary Korp, the Director at CBARC.
All right, well, he might join us in a little bit. So first of all, does anybody have questions about the videos that they've seen from this group?
This is Ernie Moore. I had a question for Don on the video, and then for Stuart, I just throw them out real quick. I asked Don about what showed up on the plant tissue samples is sort of consistently low in the basin here. And then for Stuart, I had a question. Like, I was shocked that when you chemically washed the soil, it came out black and gray, like granite, and the brown stuff you see is actually organic matter. That was very interesting. So I got it. I enjoyed those two videos. So anyway, I'll throw those out.
Expand. We talked a little bit at the beginning here, but I'll expand on that. In general, through the region, we're low on micronutrients, and that's one reason to be soil testing and tissue testing for those. And traditionally, we haven't applied boron or zinc. Those are two probably most likely to be low and probably need to be applied to bring it back up to a reasonable soil test level. Some things like copper and iron, iron's probably never hardly deficient. Copper is more questionable. We just don't have a lot of information about copper in this region. There's some areas of Canada where copper's very deficient and they get good responses to applied copper, but here traditionally we haven't done that. But as time goes on, and then we keep pulling off good yields off of these fields, these micronutrients, you could expect them to be depleted so that you'd have to supply those where historically in the past you may not have. If anyone else wants to chime in, they're welcome to. If Paul's out there, I know he's done, Paul Carter, if he's done quite a bit of work with micros, so he has some good information and some good perspective on those.
I know one time we put a bunch of zinc on, one of my brothers wanted to, and I don't know if it was just specific to that variety of wheat, and he might have put on way over what he needed to, but we had 11 flat tires that year. The straw kind of turned into punji sticks out there. Is that a common reaction?
I haven't heard that, and I haven't had that experience. So I can't really tell you if that was caused by zinc or something else that year.
I'm sorry, Greg, what happened?
Oh, he just put a lot of zinc on, and the straw got extremely stiff. Now, because we didn't usually, that's the only time we ever applied zinc. We did an inference there, but Don's right. There's no proof that that was actually what happened, and it could have been just a reaction to that specific variety. And it's been so long ago, I don't even remember what it was.
Just expand on that a little bit, Greg. Straw strength is related to the structural things like calcium and carbon. Zinc is used more in enzymes and other processes in the plant. So I find it hard or difficult to imagine how zinc affects straw strength. Because at first you don't apply very much on, and where it's used in the plant, I don't see it contributing to structural strength.
Hey, Don, this is Chris Williams. So in our soil tests, we're typically deficient in boron and zinc are the two at the top. copper as well. On the tissue tests, of course, boron and zinc still show up even though we apply those. But the big one this year was magnesium, showing up on the tissue tests at both Tillering and Flagley.
And the magnesium was low?
Yes.
And what was the soil test level?
Ooh, well, that's actually not a nutrient we generally soil test for, so I can't tell you that, Don.
Okay, because if you're on a lot of soil tests, they'll do some of the bases, and magnesium, calcium, and magnesium would be on there, and generally, we don't have any issues with magnesium being really low, but it may be the ratio on the cation exchange capacity is kind of what people watch for, but in general, magnesium is not an issue, and it's not something we fertilize for.
Hey Don, I have a question. For these micronutrients, I've seen studies where a lot have been added at one point and then it's been monitored for several years. Would you recommend adding a large amount at one time and then letting that ride out over the next decade, or would you recommend adding a little bit each time you fertilize?
Well, that's somewhat dependent on which nutrient it is, but in general, I would be in favor of supplying the right amount over short periods of time, so 1 to 3 years, but not a decade-long application. One might be cost, and the other just might be efficiency. So I don't think you need annual applications, but supplying like chloride and boron and those things, 1 to 3 years, you can get adequate amounts on. The amount is pretty small, so would be mixed with other materials that you're applying.
This is Paul Carter. Can you hear me now?
I can hear you, Paul.
Okay. I was on. Apparently you couldn't hear me a while ago. Yeah. Anyway, the nutrients you're talking about, I find quite often deficient in soil samples, and zinc, copper, boron, chloride, all of them seem to be pretty deficient. So I would expect to see some response to those. And some of the plots that I've got out, I'm seeing some pretty sizable responses to those micronutrients. So especially zinc and boron. So I would advocate, certainly cereal grains are going to need the chloride, however you can get it, whether it's potassium chloride or calcium chloride, or as far as that goes, even sodium chloride would give you a good big boost of chloride on it, and the sodium wouldn't really hurt anything.
So Paul, there's a cost involved in doing the sampling and tissue sampling or soil sampling. Do you think that some growers would benefit just by going ahead and paying for the micronutrient package, that would pay for itself, and maybe you could save investigating all your soil values?
I think, Stuart, I think that probably would, because everywhere I've looked, even there at the station, those nutrients are low, and some of them extremely low. Like boron is often down below 0.1 part per million, which is extremely low. I mean, that's the minimum they report.
Thanks.
So that says, well, we think there's some there, but we don't know for sure, so we'll just put down 0.1. So I'm seeing a big response on that. If you look at your wheat heads, If you're starting to see blanks at the bottom of the heads, a very good chance it's a boron deficiency. But yeah, I would agree. Although you could do a one-time soil test for all the nutrients, and you wouldn't have to do that every year, but that would give you a good baseline as to where you're at. And I think one sample for field certainly would be worth whatever the cost is.
Thank you.
And Paul, the OSU fertilizer guide, the adequacy for boron is a half a part per million. And I think yours is also, right?
Yeah, that is the absolute minimum that they recommend. So that's not a target to shoot for necessarily. You need to be up around 1 to 1.5 to really be in an adequate range, because boron is mobile in the soil.
Via chat, we received a comment from Gary Kimnick. I might be butchering your last name, I'm sorry. And that many years ago I tried foliar applications of zinc just before heading. Got a response, not statistical, is what he said.
Well, I saw Gary on here. Gary is the former OSU professor at Eastern Oregon. He used to teach crops and soil courses until he retired. He also did research in the Grand Ronde Valley, and I don't know if that's where he did this zinc study, but I haven't done foliar zinc application, so I can't speak to that particular study. I think that late in the plant staging, plant cycle, you're less likely to see a response than if you've applied it earlier. But zinc is one of those where pH is a factor also. So if you have a limiting pH, in this case a high pH, maybe foliar zinc might have more likelihood of a response, because your soil pH might be limiting uptake. And Gary, you may want to comment because I saw you on here.
Hey, Don, Bob Johns.
Hi, Bob.
For the last 4 years, we've been soil testing and tissue testing. And I think that what the grower has to defend, do you want to max the crop out and have all the nutrients available that give the greatest potential for the yield, or do you want to maintain and just do what you're doing? And boron and zinc are two, but magnesium and copper have to be looked at, because every time we soil test, even if it's in the soil, doesn't mean it's getting up in the plant. Potassium's another one. So what we've had to do is find and we're having trouble finding the micronutrients to fly on at the right time. And so we've been using boron at the time of herbicide and time of our last, we're going over twice with the fungicides, and we're putting it back in again right at the heading or flag leaf stage. And we're seeing tremendous results from this, doing this twice. Plus, we got to look at the chlorides. And Paul's right on this. If they're, it's one thing to have a soil test. It's another thing to have a tissue test, because that really tells you what's going in the plant. And one thing that is fascinating for us, we just went to some organic farming, and this chicken manure stuff has given us every nutrient we needed in the plant, not only in the soil, but in the tissue test. Not everything comes out to the max as if it's all available. So we need to put more chicken manure on.
Well, I strongly agree with everything you said, and that sounds like a good nutrient management program. But the tissue test coupled with the soil test, soil test tells you what to apply. Tissue test is telling you how much is getting into the plant, and if you're applying materials and it's not getting into the plant, then either there's some soil chemistry issue or there could be some biological reason, like root disease or something else that's affecting that. So using those in tandem and using them consistently at the same time to understand what's going on, I think everybody should be moving toward that goal. And I would recommend having like benchmark areas in your field that you go to and sample the soil test, and then those same areas become your benchmark for your tissue tests. And on wheat, it might be if you're going to only do it once, it might be at the end of tillering, but you can do it at other plant stages, but at least do it at the end of tillering.
Yeah, this is Paul, and I would agree with that as well. I think we can do some tandem things. Bob, what you're seeing is exactly what I'm seeing. We're getting responses for those products when we put them on. And I know that boron at pre-bloom on garbs and peas seem to make a tremendous difference in yield. You don't want to be any later than that. So I would expect a similar kind of response probably in wheat if you catch it pre-heading or right at flag leaf. So that sounds like a very logical thing to me.
Just backing up Paul Carter's comment about seeing the boron deficiency and zinc deficiency across the Columbia Basin. Last year we tested our winter sites in Dufur, Morrow, Kent, and Lexington. And all of them came up deficient in boron, and all but one of them came up deficient in zinc. And the tests are $50. Obviously, if you're going to be doing a lot of tests for different parts of the farm, it adds up to more than that. But usually just to be efficient with our trial sites, we take a lot of samples and then bulk them. And that gives us at least an idea of what's going on. I know it's not the ideal, but it's better than nothing, I think.
You were talking soil test, right? Right?
Yeah, that was soil test. For variety tissue test, I think the variety would become a confounding factor there.
I had a comment about the chicken manure. All manures are a complete fertilizer, so they have the whole host of other micronutrients as well. It'd be great if we could all use manures. There's just not enough of them to go around, and the logistics of applying manure on every piece of ground just aren't there. So if you have access to manure and it's not too expensive, it's great stuff. But we're limited. That resource is limited. It's not where you want it, and not everybody can afford to do it.
Well, practically too, the nutrients in the chicken manure are coming from nutrients that are coming off the previous crop somewhere. So, if we can use manure, but we're never going to be able to increase the total amount of micronutrients in the system. I don't think. I'm not a nutrient specialist, but.
Hey, Dawn.
I like to also add that manure has higher pH. So if there is a problem with the pH, some nutrient becomes more available with change in the pH. So that might be another issue in addition to adding the nutrient. Also will change the soil pH.
Hey, Dawn.
Yes, Bob.
Our cost was only about $500 an acre, so you might want to look at the value of your crop before you do this.
Okay, so are you going to double the rate now because it's only 500?
No.
Well, Paul, I'd like to add a comment about that soil pH, and that's one of the things I've been after for a good while, and the soil pH is going to limit a lot of nutrients. Even though the soil may show nutrient availability, it may not be available to the plant because of the soil pH. So it's one of the things that we've got to work on. And I've got a plot there in the Walla Walla area that's showing a drastic availability of nutrients where I put lime on almost 7 years ago. I put a ton of lime, and the barley that's on that this year is just phenomenal where the lime was applied versus where it wasn't.
Paul, what was the pH of that soil when you started?
The top 6 inches would have been somewhere between, I'd say about 4.8 to 5.8, well, 5.5, somewhere in that range. And when we put the lime on, the top 3 inches have jumped up to about 6.2, 6.3. The second 3 inches are still in that 5 or a little bit below her. But I've got a couple of aerial images that just unbelievable this year, the difference that it made. And this is almost 7 years later.
What was the soil type? How much clay?
It's I think a Walla Walla silt loam. So it's pretty, from my background, it's pretty minimal clay content, really.
Yeah.
It's a strong silt loam.
Yeah, clay content would be around 20%, 18, 20%.
I'd say that's probably right. But I've seen some pretty fantastic yields where we had the lime and the micronutrients applied. Last year we saw a 17 bushel difference on soft white winter wheat where I had lime and micronutrients applied.
Wow.
And the control yield, I think, was 111 bushel. So the treated was up to almost 130 bushel to the acre. But 17 bushels, that's a lot of money.
How much lime did you put on, Paul?
But we put 1 ton to the acre on. And I've not been able to harvest that plot every year because of time and money, mostly money, but I've harvested 3 out of 5 years. And those 3 years, the additional yield would have paid for all the inputs.
That includes the lime?
Yes.
What did it cost per acre for the lime, 1 ton of lime?
I think we spent about $150 on that.
Okay.
Can't remember the exact number, but the micronutrients were somewhere in that $50 range, and that was only one application of all of those. We've not applied anything else since that initial application.
Paul, what type of lime did you use?
We use the liquid lime because of availability and application ease on, lime's kind of hard to spread if it's in the dry form. And we were putting it on 10-foot wide strips, so you got to control that pretty well. And the liquid worked really well for that. But there are a lot of other sources. I shouldn't say a lot of other sources. There are other sources out there that work well and don't break the bank totally. It's cheaper than $500 an acre for chicken manure.
Deb, could you do the survey on that question number 2? No. Okay.
All right, they're all grouped together, Dawn, so we're going to push out all 3.
Okay.
So for everyone, if you would just mark the polls for Dawn, and then I'll give you a couple minutes to answer them all, and then we'll show the results to everyone.
Hey, Dawn.
Yeah.
I tuned in late, so I didn't hear all the questions about tissue sampling. Did you talk about the differences in tissue sampling for soft white versus DNS?
No, we have not covered that yet.
The range of what you like it to be?
No, we haven't talked about that.
Okay.
The difference between soft white and the hard reds is you're trying to make protein on those red wheat, so the nitrate nitrogen concentration in the tissue, especially the correlation at flag leaf emergence, the range is higher. If I remember right, it's like 4.2% is the critical level. If you're above that, you're likely to make protein. If not, if the system allows you, you could apply more nitrogen at that time, especially if you're irrigated. And Dusty, you may be closer to those numbers than I am. I don't carry that around in my head. So if you've got some knowledge on what to expect there, you're welcome to share that.
Well, I've kind of tried to look for some support information on what those ranges really should be, and from what I'm seeing is the numbers are kind of all over the place. So I was wondering if you had one go-to place to look for those numbers. They're seems to be more and more DNS being grown, and just want to be able to relate to the growers when those tissue test results come back. What are we really looking for?
Yeah, the Brad Brown down in Parma did work on that tissue nitrogen, and that usually if I have a question on it, that's the work I look at, but there's certainly other stuff. Mark Alley at Virginia Tech, they've done a bunch of work on tissue testing on wheat, not so much hard wheats, just wheats in general. And so Virginia Tech has some recommendations, but that's a whole different growing system than what we have. So the further from our cropping systems, the less likely that those numbers may be reliable.
So do you or your supplier take tissue samples or write 50-50, Don? And then number 2, indicate if you're using tissue testing to assess your nutrient management and fertilizer programs. You have 44% were yes, 39% no, 17% were don't know. And then at what crop stage are you taking tissue samples? And people could mark multiples of these, but looks like 28% were at the end of tillering, 33% at flag leaf fully emerged stage, 0 at flowering. You have 28 who don't know and 17 who don't care.
All those numbers are good, except for the ones that don't care. I'm not sure if they're just being reacting to my last answer, maybe.
Oh, Don, when you asked that first question, was your intent to figure out, is it 50% of people are not sampling or not doing tissue tests? Is that how you read that?
Yes, that's how I read it.
Is that kind of what you would expect across the region, or do you have any idea on that?
I really didn't know. I guess if I had to anticipate that answer, that's probably pretty close to what I would have anticipated. I'm glad to see it's that high. I think that's one thing in the future for fertility programs. This tissue sampling should be incorporated into the soil testing and the nutrient management. So doing it consistently in time and over time, and at the specific crop stage each year, I think that's will provide useful information as people develop better nutrient management programs. And one of the things that the CSP program, I know that's incorporated tissue testing. So if you're participating in CSP, that was the requirement. And so knowing when to do it and how to interpret the results, if you're required to do it anyway, might as well take advantage of that information if you're in that program.
Do we have any questions about any of the other videos? We've got a few more minutes left before we move on to weed management.
This is Paul. I don't have a question, but I'd just like to make a comment before we get off of it. You know, Don has certainly brought up the soil testing and tissue testing, and I think I agree with him on it. One thing I would like to see done on soil testing in particular is to, when you sample a field, get one sample from the higher production areas and one from the lower production areas and see what the differences are. You know, one of these days we're going to be able to do more and more variable rate application of products, and it would be very helpful to know what is missing in those lower production areas. So I would be cautious about trying to aggregate all across the field the high and low areas. That's a personal opinion of mine, but I think it's helpful to know what's missing in those low producing areas versus the higher producing areas.
I agree with Paul on that, and you know, there are growers who are doing variable rate application and have management zones in their field, and maybe eventually we work toward sampling from specific management zones. That does drive up the cost of testing, but at least you know what's going on in your field.
I agree that all of the soil samples that I will be pulling will be from GPS management zones, repetitive sampling sites, and they'll be representative of each management zone in each field. So I think it's important to make sure that you're getting all of those low production areas, medium production areas, and high production areas sampled and keep them separate so that you know exactly what's going on. And if you can GPS those points so you can build a history for each point. Do some tissue sampling and then maybe do some post-harvest soil testing also back to those same points. You start gathering information that's useful.
For those of you who might not know Dusty, Dusty is a retired federal employee, but now works as a consultant soil sampler in Wasco County and area down there. So he has a number of years of experience and is out in the field a lot.
Dusty?
I'd like.
Excuse me.
Go ahead.
Oh, there's not as much availability of that tissue sampling here in Sherman and Wasco counties, is there?
I don't have as many customers. Let me stop and think. Tissue sampling, I have one customer in Sherman County, but I'm always willing to go to Sherman County and tissue sample if someone requests it. Got probably about 1,000 soil samples to pull out of the Chem Fallow side coming next few months, and then away from Wasco to Sherman to Klickitat to Yellow counties.
Yeah, the tissue sampling isn't as prevalent here in Sherman County, so.
I think the CSP program is probably driving that need and that request.
So, Ernie, if you start tissue testing, you'll double Dusty's clientele, I'm sure in Canada.
I have to do that.
This is Brian Tuck. Hey, for Paul Carter. Paul, are you still seeing a steep decline in pHs up in the Palouse, and also a continued decline in our area? Or are you seeing things kind of sort of leveling off at all?
Well, you know, pH changes usually happens over longer periods of time to really observe the changes, but, you know, we're certainly not improving, and we won't until we put lime on. But, yeah, I would say, yes, they are continuing to decline. Over a 10-year period, you're probably going to see maybe 1/10 of a point or something like that drop. Hero might have some comments on how fast some of this might happen, but I know that when you start getting some pretty low numbers, you can fall off the chart pretty fast.
Also, it depends on how much nitrogen fertilizer you are adding to these plots. The higher amount, the lower the pH you will get. So it's dependent on.
And I think when the pHs get into those upper 4 to mid 4 pH ranges, they can start dropping really fast if you're not on top of it. They can go from 4.5 to 4 pretty fast because you have other factors starting to happen in there, and aluminum is part of that issue. Aluminum can add to this problem.
I agree. It's also affecting the micronutrient very fast in that range.
Right.
And, you know, we were really seeing that, you know, especially in the seed zone where it really was low, very low, you know, and so concerned that we continue to keep dropping that pH and where we're planting our seeds, you know, that we're going to have obviously a significant problem here one of these days.
Well, we've certainly seen that happen in some areas where just all at once it falls off the chart and nothing will germinate. And we saw that happen up in Rockford, Washington. Wow. You know, the pH has got in the upper 3s and nothing would germinate then. But it happened over a 2 or 3 year period when it just really went low in a hurry.
Has there been any industry response up there, chemical, you know, the fertilizer industries to, you know, make the product cheaper? And, you know, I mean, is it becoming more of a trend to where the cost would be reduced a little bit of the product?
Cost of what products?
Of lime and, you know, to get your pH back. Is there,
okay.
Is there any?
I'm not aware of anything that has happened in the industry other than I know that there's a lime supply over in Grangeville, Idaho, and they're starting to get into it. They're selling ag lime in the range of $50 to $65 a ton. That's still pretty expensive, but it's a whole lot less than $200 or $300 a ton.
So it's the thinking still to try to put lime with the seeds in the seed zone to mitigate the fertilizer that you're putting on to at least not make it any worse. Is that kind of maybe the primary response at this point until we find out more?
Well, we've certainly seen some tests done that way and seen a bit of a response by putting either a pelletized or a liquid lime kind of in furrow with the seed because it's not going to hurt the seed any. Now, if you put some of the quick lime or something like that in there, it would. But if you just use a pelletized or a liquid lime there, you're going to really magnify root production just at phenomenal rates. It's been amazing what I've seen happen when you do that. But that would be, in my mind, that might be the most efficient use of a small amount of dollars to begin to make some difference.
Oh, do you think that would also be one where you'd recover costs on a single application?
Yeah, I think Well, I'll relate an experience that was reported to me over in the Horse Heaven Hills. And the fellow was doing some experimental with liquid lime in furrow with wheat, and the production area is somewhere around 25 bushel the acre. Horse Heaven Hills, there's low production compared to what we're used to over here. He said he put on $14 an acre lime. Now, I don't know how many gallons that was because he used liquid lime, but he said it paid its way. So they got their money back plus a little boost. And if you can do that on 25 bushel wheat, you must have gotten a pretty good response.
You know how long that buffering effect will last, Paul? You're going to have to repeat that every year, every other year?
Well, if you're only treating in furrow, I'm assuming you're going to have to do that almost every year.
That's kind of what I was thinking.
But if you're recovering your cost plus a little bit more, it's maybe it's kind of a no-brainer to start doing that and maybe begin to make some changes in pH rather than watch it go on down. Now, these are all speculation and opinion thoughts here. So, I mean, what I reported that happened over there was actual, but how long is it going to last? I don't know.
And this is Brian Tuck again. Maybe I'm wondering for like Bob Zemetra, and others that are doing breeding, are we working on wheats that maybe tolerate a little bit lower pH along with this, using lime in the furrow with the seed to try to at least mitigate some of the problems. So having maybe a multiple pronged approach on this for the long term.
Well, we've inadvertently been making selection based on soil acidity because of where we do our variety testing.
I think
if we're growing, go ahead.
First off, you're right, is if we're breeding wheat or testing wheat in our at our sites that have lower pH and we select higher yield, we're actually picking wheat that passively selecting for the resistance. We have a site here in Hislop that a third of the field is low pH and 2/3 is high pH, higher pH based on putting on lime. And so we are testing our advanced limes for ones that perform at the lower level. I know Aaron Carter has been running tests on low pH to look at specifically the issue you're talking about of the banding, that if you can get the roots to get started and grow through the band, the plant's fine. What we test on for acid soils here is the whole soil profile is low pH. So we need a plant that actually can grow fairly well. And there are differences. I can tell you this has been a problem, even going back to my postdoc days. But I do remember the first year I was at Idaho, so in '85, Bob Mahler had a lime test out to look at the low pH on cutover forests. So it's been an issue for years, and there is some variation tolerance, but if you're talking about getting down in the 4s, I'm not sure we can breed for a wheat that will tolerate that low a pH.
Any last questions or comments before we switch over to the wheat session?